So we're talking about exponential growth and decay in this section. So usually in previous years, when you talk about exponential growth and decay, you're just given those formulas, right? Here we're going to come up with the formulas. We're going to come up with the equations. So when you have a differential equation, right, like dy dx is f of x g of y. So look at how this is different from what we were doing here. So look at what this is. Here we have dy dx, and then we've got a function in x, right? So in your function here, you only have one variable up here. What if you had cosine of x and then some other, like times y, or e to the y, or some other function of y? So that's what we're talking about here, where you have dy dx, but also you have that equals a function in x times a function in y. When you have that, we say that that is separable. So what you could do is you could group the function of y with the dy, the function of x with the dx. And the way that happens is, remember how before we were moving the dx over to that side, right? And you would get like dy equals blah, blah, blah dx. Well, now, yes, you move that over there, but also the gy, the g of y, you're going to move to this side. Okay? So, if you have dy dx equals f of x g of y, the dx is going to move over. Okay, so here you have your f of x, g of x, and then your dx, right? Because the dx just moved over. But then, this is y, sorry. But then your g of y is going to move here. So here you're going to have dy over g of y. And anytime you've got dy, that really won't exist alone. You have to now take an integral of that. So then it ends up as integral 1 over g of y dy f of x dx. Okay, so let's do that. This process is called separation of variables. All right? All right, so here. Okay, so use it to solve, and look, it's an initial value problem. Indicate the domain over which the solution is valid, so lots and lots of things to happen here. So what we're going to do is we're going to isolate the y. All right, so the dx is going to come over here. All right, so what do I have now? I have dy is equal to x over y dx. Now what do I do with the y? Multiply both sides by y. So I have y dy is equal to x dx. Now what? Take an integral of both sides. Okay? And now when you take an integral, this is going to be y squared over 2. Yeah, it's plus c. And then here you're going to have x squared over 2 plus c2, remember? And then the c's combine, and you have plus c. And now you plug in. So you plug this into here. So we get 1 over 2 equals 2 squared over 2 plus c. So that would be 2. So 1/2 is 2 plus c, and c is negative 3 over 2. Okay? Now, well, it's just like what we were doing before. Remember how eventually, yeah, in the beginning, we had gotten like plus c1 plus c2, remember? Where was that? Yeah. Remember that? And then we combine them and just put it on the right side. Same reason. Okay, so now let's plug it back in. So we're going to plug it back. What was our equation? Y squared over 2 plus x squared over 2 plus, equals, what is it? X squared over 2 minus 3 over 2. My equation was this, remember? Y squared over 2 equals x squared over 2 plus c, and that's what c is. So now I need to solve for y. Right, multiply everything by 2. You can, it's the same. So y squared is equal to x squared minus 3. Take a square root. Now we have y is what? Plus or minus the square root of x squared minus 3. But this is an initial value problem. You have one particular solution. So how do you know? Do you take the positive square root or the negative square root? Yeah. Okay, there it is. You have to use the initial condition to check. So check using the initial condition. When you plug in x equals 2, you should get positive 1 for y, right? So check initial condition, which was y equals 1, x equals 2. So for example, okay, so look at what I have. 1 equals plus or minus 2 squared minus 3, right? 2 squared minus 3, that's 1. So you should take the plus sign in order for it to equal the correct y value. All right, so it's this one. Therefore, you guys know that's therefore? Y is positive x squared minus 3. Huh? No, because what you want is an initial, what you want is a particular solution. You want an equation. Correct. You want an equation like y of x. Okay? So, let's run through the process for a minute. We separate the variables. We solve, we integrate like we did yesterday. We find c. Then you have to check to make sure you have the right domain. So when it says indicate the domain over which the solution is valid, you know, that's partly what we're doing there. Here, okay?
That's the domain.
That's, yeah. Okay, let's do one more. Okay, so dy dx okay, I'm sorry, dy dx is that, right? So I'm just going to move the dx over. So dy is xy squared dx. Okay, now what is the y part that I'm going to move over?
Y squared.
Y squared, right? So I'm going to divide both by y squared. So the way I'm going to write that here is 1 over y squared dy is equal to x squared dx. Integrate. When I integrate, can I rewrite this as y to the negative 2 dy? So how does it look when we integrate?
It will be y over negative 1.
To the power of what?
To the power of
Negative 1 equals
x plus 3 over 3
plus c. So this is negative 1 over y equals x cubed over 3 plus c. Is that right?
Yes, it is.
Okay. So what is my initial condition? Here, when y is 1, x is 1. So negative 1 over 1, so that's negative 1 equals 1 over 3 plus c. So C is -4/3. Okay, where was my equation when I integrated? Here, right? So that's what I'm going to plug into, this one. So -1/y, I love this problem because there is a cute little trick here. -4/3. Now, you know what? Let's just get rid of that negative. So let's make it, let me see, do I want to get rid of the negative? Let's not. That's it right there. How do you solve for y? You flip it, right? You don't cross multiply. Because what is this? This is -1/y equals x cubed minus 4/3. So if that's 1/y, then when I flip it and I do -y, that's equal to 3/x squared minus 4. X cubed minus 4. So then y equals -3/x cubed minus 4. Right? And here we only got one choice. So I don't have to do that other part about deciding between the two. That's it. That's the answer. Yep. Yeah.
Is it always going to be the case where you have x is over something and then the c is also going to be over the same number?
No.
No, it just happens to work out for these two.
Yeah, because we had a whole number and a fraction, and then when you add those, you're always going to get the same denominator. Okay, so dy is 2xy dx. So that's 1/y dy is 2x dx. Is everybody okay with that?
Yeah.
Okay, integrate. Oh my God, what do I get here?
The same thing.
ln of y. Yeah. Right, because 1/y is ln of y, right? So this is ln of y equals x squared plus c. So now, initial condition, ln of 1, when I plug in a positive value, I no longer have a need for my, oh, you're done? Oh my, it took me more time to take the desk outside. Thank you. Okay. Right, so when I plug in a positive value, I no longer have the need for the absolute values. Equals 2 squared plus c. So how much is c? 1.
I thought you wrote half of absolute value.
I think there was an extra chair.
No.
Oh yeah, there was an extra. So ln of 1 is 0, so c equals -4. So my equation was ln of y equals x squared minus 4. Now this is my favorite part. Okay, how do I solve it? E to the ln of y is equal to e to the x squared minus 4. E and ln go away, so absolute value of y is equal to e to the x squared minus 4. Okay, but that's not a solution. You can't leave it in the absolute value. So then what's y? What does absolute value mean?
That's positive only.
Positive or negative. Okay, absolute value conceptually, what does it mean? It's the what? How far away it is. Okay, so the distance is this. So if you say y is equal to 5, that means, right. So what's my y? Where is my y? It could be here at positive 5, or it could be here at negative 5. So y is plus or minus 5. So y is plus or minus e to the x squared minus 4. Huh? But you have to pick one. And how do you pick one? You plug in the 2, right? When
Is 0 equals 0?
e to the 0 is positive 1, so I have to have the positive out front. So y is e to the x squared minus 4. If you have e to the 4 times e to the x, how much is that?
E to the 4.
4 plus x, or x plus 4, right? If we do it that way. So if I had e to the x plus 4, can I write it that way?
Yes.
Yeah.
I can. So if I had e to the x divided by e to the 4, what would that be? E to the x minus 4. So how can I write that? E to the x squared over e to the 4. I will take both on the test, but the reason I'm going through this is in the book, you know, when you have like an assignment at some point and the book gives you the answer in that form, you know that the two are together. Now, in AP, it will never be in this form, right? In the real world, we never leave it in this form. Okay, moving on. I love this stuff. Okay. So, the law of exponential change, right? If y changes at a rate proportional to the amount present, what does that mean? If something, let's say, is leaking out of a container, right? And if you double the amount of water in the container, it doubles how fast it's leaking out. If you triple the amount of water in the container, it triples how fast it's running out. That means that the rate something is happening, how fast something is happening, is proportional to how much you have, right? Okay? That is what we say. That is how, what, you know, we say that the rate is proportional to the amount present. Okay, what's rate? Rate is dy dt. And if something is proportional to something else, you would have learned this like back in the day. If two things are proportional, so if dy dt is proportional to something, if one increases, does the other one increase? Yes, by the same amount. So the equation we write is k times the variable. In this case, this is the equation for direct proportion. The most common place where you see this is the gas laws in chemistry, right? PV equals nRT, right? And then when you have like Charles' law, Boyle's law, okay? So for example, temperature and volume, how are they proportional? Temperature and volume are directly proportional. When the temperature goes up, it expands, so the volume expands. So V is equal to KT, right? This is directly proportional to that. This rate is directly proportional to the Y. Okay, so when we have an equation like that, and if we say at t equals 0, the initial amount is y naught, right? Then when we solve that equation, this is what you get. Where have you seen this before? Always. Everywhere. Always. This is where it comes from. It didn't fall out of the sky. It wasn't like it was raining one time and this just also fell out of the sky. No. There was this equation. We solved this equation using separation of variables, and then we got out of that y equals y naught e to the kt. This is like one of the most useful equations that we have in math and physics and everywhere else. Okay, y is the final amount, y naught is the initial amount. K, we call k the growth constant if k is positive. And it's a decay constant if k is negative, right? So if something is decaying, radioactive decay, it'll be e to the negative kt. If something is growing like population, e to the positive kt. Okay, this is also where continuous interest comes from. Okay, I'm yelling because I'm so excited. This is also where the equation for continuous interest comes from, right? Interest added is continuous. If interest is added continuously and the rate is proportional to the amount in the account, right? The more you have, the more you're getting. Then that's what you get, differential equation, blah, blah, blah. And then you have A equals initial e to the RT. A equals P e to the RT. That's where it comes from. Okay? Yeah. That's the thing. That's the thing. Because bankers were like, we can't deal with A now. We need to have P for principal. Okay, so they put in P. Okay? Okay. So, take a look here. Population Y grows according to the equation this. Okay? Where K is a constant and T is measured in years. If the population doubles every 10 years, then what is the value of K? All right. So my equation is dy dt is equal to ky. Okay. Now, what I also know, okay, that, okay, so we're not gonna go through how I solve this, all right? But I want you to know that if you have this equation, dy dt is equal to k times this variable, then the equation that comes out of that is y equals y naught e to the kt. I'm not going to go through how to solve it. We solve it in AP, but it's separation of variables. It's really cool, actually. But the end result is y equals y naught e to the kt. Now, it says it doubles every 10 years. So, that's your time, exactly. So 2y naught is equal to y naught e to the 10 times k. Now, what's going to happen to the y naughts? Cancel. So I'm going to end up with e to the 2 equals e to the 10k. Now, most of the time in the real world, if it doubles every 10 years, if it triples every so many years, blah, 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 we normally skip this step. So if it's going to triple every 20 years, we say 3 equals e to the k times 10. Okay? If it's half-life, then it's 1/2 equals e to the however many years k. Okay?
But you want us to show it?
Up to you. So ln of, okay, so now ln of 2 equals ln of e to the 10k. ln of 2 equals 10k. Divide by 10, divide by 10. K is ln of 2 over 10. And in calculus, that's a perfectly good enough answer. We don't need...
What does that say, 15? No, K.
K, sorry. We do not need... But yeah, so it doesn't need to look like, you know, 0.0693, whatever. It kind of, sort of is. Okay. A puppy weighs 2 pounds at birth. Okay, so listen to this one.
On the last problem, why does the y, the initial y, become a y? Now it's like initial y equals...
When you solve this, I solved this behind the scenes.
Oh, yeah.
When you solve this, there is a process similar to this.
But we don't need to...
We don't need to do it. So you end up with e to the k minus c, and then you do this, and it becomes c e to the kt, and that c we call y naught. So you solve it like this, which we didn't do. I just told you that every time you start with an equation like this, dy dt equals k times y, the solution is always going to be this equation. Okay? Okay.
Like, the y just becomes y naught.
Why not? Exactly. No, because that's how, it has nothing to do with doubling. Anytime you solve this, That's the solution. It's this. Let's do the next one and I'll tell you. A puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. If the weight of the puppy during the first 6 months is increasing at a rate proportional to its weight, how much will the puppy weigh when it is 3 months old? So that part right there, rate proportional to its weight, is dW for weight, dt, is equal to kW. Okay? That I got directly from the phrase at a rate proportional to its weight. Yes. This I must see. I must see this. Now that is solved as, when you solve it behind the scenes, machine solves it for you, I get this variable W equals to W naught e to the kt. So you see how it's automatic, right? So if we compare it to what we did before, I have dy dt as ky, y equals y naught e to the kt. When it's with the w's, w equals w naught e to the kt.
Oh, so
it's
y,
automatic.
So y just equals to y naught.
Exactly.
I thought you were adding the y naught.
I'm not. It comes out of the solution. I didn't show you the solution, so that's why you feel like there was a piece missing.
Okay.
Yeah. Maybe next week I'll show you the solution. Let's use it first. Okay. So I'm yelling again. Okay. I feel it here. Okay, because it's so exciting. Okay. A puppy weighs 2 pounds at birth. That means at birth, what's time? 0. And then it weighs 3.5 pounds 2 months later at t equals 2. So let's put all this in. Initial amount. Yeah.
T can be whatever
Unit, yeah. Usually it's yours, but yeah, it's whatever. It could be hours for bacteria. No, because no, it's the same.
As long as the months are the same.
Yep. Yeah. Okay, so final amount 3.5 equals initial amount e to the k times how much time has elapsed? 2 months. Okay, so 3.5 over 2 is equal to e to the 2k. Okay, now don't be looking for your calculator because it just adds steps. So ln of 3.5 over 2 is equal to ln of blah, blah, blah. So it's just going to be 2k. It is 2. No, this is final, this is initial. So now k is ln of 3.5 over 2 divided by 2. Okay, are we done with this problem?
No, we're not.
No, what's it asking us? How much will the puppy weigh when it's 3 months old? So what's W at t equals 3? So now I need my equation back. My equation is W equals W naught e to the k. K is that mess of a number here times t. So W is equal to W naught, which is 2, e to the ln of 3.5 over 2 all over 2 times 3. Okay. T for 3 for t. All right. So we plug this in as is, right? We always, especially in these problems, we minimize the number of intermediate steps and we minimize the rounding in the intermediate steps. It's a thing. It's called rounding error.
The E and L are not cancel out.
They're No, because ln of blah, blah, blah over 2. So there's like a whole bunch of stuff happening. So it's going to be 2. Whoops. So it's going to be 2 times e to the ln. How much is it? 3.5 over 2. All over 2. I should have put parentheses around it. All over 2. Parentheses times 3. Yep. Yep. Right? Look, that's how it looks. Is that right?
No, the ln is right still.
You're taking ln of 3.5 over 2 over 2. You're taking it of the first.
I think it's ln 3.5
It gotta be
over
ln
2
3.5 over 2.
next.
Then
over
divide that
2.
by 2. Then multiply.
Just ln of the numerator.
Yeah.
Oh, sorry. And okay, so that's awesome, right? 4.63 pounds. So you would have recognized, right, that if it was already 2 pounds at birth, that at 3 months, 1.3 would not have been correct. So awesome, way to go. So W is 4.630 pounds.
You want that 0 there?
3 decimal places, so yes.
Right, but even if it's a 0.
Correct. 3 decimal places. Okay? All right. Now, don't leave units out. Don't leave units out. Okay.
Real quick, we don't use the interest formula just with money.
Right.
Gotcha. So we don't have an equation with
I haven't used it. We've done so much of those in algebra. Okay. During a certain epidemic, the number of people that are affected at any time increases at a rate proportional to the number of people. So right there it is again. So dp dt is equal to what? Kp, which means P is equal to P naught e to the kt. There. All that just from the phrase that I've highlighted in blue, right? All that immediately. Okay? So, yeah.
Real quick, for the variable, what if you did like I for effective?
It's fine. I do like I for current, but sure. it's totally fine. If 1,000 people are infected when the epidemic is first discovered, so what is this? At t equals 0, right?
that's the original.
Right? And 1,200 people are infected 7 days later at t equals 7. How many people are infected 12 days after 12 days after the epidemic is first discovered? So, same situation. So, 1,200 equals 1,000 e to the k times 7. So first you have to find k, right? Because everything is the same for each of the problems. What's unique is the value of k. That is unique to the specific case at hand, okay? So you first have to find the k. So you cancel out 2 zeros here. So we have 12 over 10 equals e to the 7k. That's 1.2, is that right? So ln of 1.2 is 7k. So k is ln of 1.2 over 7. Almost. So now what's p? It's 1,200, I'm sorry, it's 1,000 e to the ln of 1.2 over 7 times 12. So how much is that? More.
1,300.
Okay, so what is it exactly? 136. Okay, so here, because this is the number of people, I round down. So it's 1,366 people. It's not, 0.9 is not one person. It's like one person, it's like, okay, yeah. No,
And they don't have
No.
maybe one person